In this video, let's learn how to increase security and add further controls to your API you've just created in AWS API Gateway. In the previous video, I showed you how to secure your API by generating keys and attaching them to your APIs within AWS API Gateway. And then we configured your API heading to test out your APIs. Keys are a great starting point to securing your APIs on the internet, but that's not enough. Continuing from the previous exercise, let's say we have created a key and securely sent it to a trusted party. But how can we be sure who is using the key over the internet? How do you know it's the intended trusted party calling the API and not someone else? We do this by requiring the clients to present a valid digital certificate before accessing your API. You can verify the identity of the requester and only then establish a trusted communication channel. This approach prevents unauthorized access and prevents sensitive data from malicious actors. Additionally, it allows for fine-grained access control where you can restrict the API access to only the trusted parties with a valid certificate. In our upcoming video, let me demonstrate how to create and manage digital certificates, generate thumbprints for authentication, and implement a policy to enforce certificate-based access control for APIs. Stay tuned to learn more about how to enhance the security of your API infrastructure. First, let's understand the process. The trusted party, let's call them Client A, needs to create a digital certificate. This certificate serves as a digital identity for Client A. Once they have their certificates, they'll provide us with their client certificate. Now, we take Client A's client certificate and generate what is called a thumbprint. Think of a thumbprint as a unique identifier derived from this certificate. It's like a digital fingerprint. Next, we set up a policy in our API to recognize this thumbprint. This policy essentially tells our API to only allow access to clients whose thumbprint matches those we've specified. So, each time Client A makes a call to our API, we check the thumbprint included in their request against our policy. If it matches, they're granted access. If not, access is denied. This process ensures that only trusted parties with a valid digital certificate can access our API, adding an extra layer of security to our system. Now, let's dive deep into the practical steps of creating a digital certificate, generating a thumbprint, and setting up the policy in our APIs. Follow along as we enhance the security of our API infrastructure. In the real world production environments, clients would be expected to provide us with a CA signed certificate. These cost money. For the purpose of this hands-on demonstration, we will generate a self-signed digital certificate. Let's go ahead and create a self-signed digital certificate using OpenSSL.
So firstly, let's install OpenSSL in our system. I recommend you opening the wiki link. After that, you can see OpenSSL for Windows. Now on the right side, click the link. Now after this, click on Windows 64 OpenSSL. So after that, click on the second link. It's downloading. So after it's downloaded, open the folder and open up the installer. Accept. Next. So after the installation is done, open your command prompt and type in OpenSSL. So by default, it's not gonna show up. It's gonna show up some error like saying command not found. So what you need to do is you need to open up your settings and search up environment variables. So you need to click on edit the system environment variables. After that, environment variables, and under the system variables you need to find path. So you see go path and click on edit. So we need to add a new path. So go back to the program files where the OpenSSL is installed. Click on program files, search OpenSSL. There you go. Get inside bin and copy the directory. After that, get back into the environment variable settings and click on new, and you can paste in the path and click OK. I've already done it, and after you click OK, you can move it to the top or bottom, but it doesn't matter. After that, click OK on everything and get back to your command prompt and type in OpenSSL version. So yeah, as you can see, the OpenSSL is successfully configured in your Windows system. Now let's go and use the OpenSSL command to generate a self-signed certificate. Let's use this code. You can use this code. So it generates a new RSA private key and a self-signed certificate, which is valid for 365 days. So it will prompt you to enter information such as your country, state, and other common name. You can either fill in or leave it blank by pressing enter. So after you put in your code, press enter. I'm going to share this code as well. After that, put enter. So it has generated a RSA private key. So enter a passphrase. I'm just gonna give CERT, sir. Then sir. Now your country code, AU, state or full name. Just write NSW. Locality. Just you can just type anything. I'll just give Sydney. You can just leave it. Just press enter. Common name. Just write in your name, address, now after the RSA private key is generated, we need to export the certificates. After that, we need to export the certificate. So for that, let's convert it using this command. OpenSSL PKC export out certificate the PFX in key and perm insert that perm. So this command will create a PKCS file, which is a certificate file that includes both private key and the certificate. Click on enter. So the passphrase for key perm, which we set, so which was ERT. Just enter the password and passphrase. I'll just put sir. So again, sir. So yeah, it's exported. So before generating the SSL certificates, make sure you create a different directory for the certificates to store it. Now I'm going to create a directory, so let's get to downloads. After that, I'm going to make a directory for certificates. It's done. Now let's use the command to generate the RSA private key and a self-signed certificate, which would be validate for 65 days. So it's going to prompt you to enter your information. So let's enter a passphrase. You can choose whatever you want. I'm just using cert. Verifying CERT, country name AU, state, province, and Chicago. You can just choose to not enter, just simply press enter. To convert to PKCS, so for that, use this command. So this will create a certification PFX file that includes both the private key and the certificate. Click enter. So enter a passphrase. You can put any phrase. I'm gonna still use cert, CERT, so it's easier to remember. CERT, verifying the password, CERT. So that's done now. Now you can get back to your directory and look at the files. So as I created a new directory, certificates and the downloads, so let's open that, and as you can see, we have the certificate keys and the signed certificate, which we can use later on. After the certificates created, we need to store the certificates. You can choose to store in your current user profile or in the local machine. I'm going to choose local machine. Click next. Yes, next. Just give it a password, cert. Next, finish. So that's done. Now after creating thumbprint, let's go to AWS console and open our API gateway and create a policy. So on the left hand side, make sure you're on the get in resources. On the left hand side, click on resource policy and create policy. So in this policy, you need to provide this template. So in the resource, make sure you put in your own reason, your account or API ID, and under the thumbprint that we generated earlier. So as you can see, this is my thumbprint. I'm gonna put it in under the thumbprint. And for the resource credential, you can get back to your DB demo function, lambda function, and you can just copy this address and paste it on the resource. That'll include all resource path and your API ID, account ID. After you have put in the appropriate values for the API and certificate thumbprint, click Save Changes. So the policy has been saved and applied for our API. Alright guys, now let's go and test our API request with and without our SSL certificate. So for that, let's open up Postman first. So when you open up your Postman, make sure you're selecting get request and the URL section, paste your API endpoint and make sure you select get method. After that, click on send. So here we go, it's denying access. Now let's add our certificate in the Postman. So on the right side, click on settings, and on the left side, click on certificates, add certificate. Here you can add your API endpoint and select the cert file. After that, click on add. After that, click send. So now the API request can be made with the use of self-signed certificates.
Now let's recap. By now, I hope you've been able to create your own self-signed digital certificate using OpenSSL, created a thumbprint, and secured your API in AWS API Gateway.